After sleeping on this overnight, it occurred to me that at least for this bottom U-channel and then the one all the way at the bottom here, we don't actually need to drill the plug holes because there's nothing we have to worry about. We can weld on this bottom surface and the front there and then on the inside and bottom of the other one. So that just speeds along the construction. These are the two that have been welded so far. I have the 2.5-inch square tube in here secured and just very, very lightly snugged up with a clamp and this magnetic welding clamp here. Going to tack each end and then come back and just weld this inner seam. I did bead blast the steel and wire brush all the mill scale off, so we'll get that going. All right, I think we're set there. Now I'll go ahead and weld the entire bead here. I did not shim this in the same way in this particular setup based on the other one, how I'm welding this on the bottom without the plugs. I'm not so worried about needing that gap. The third rail is welded in, and now I'm going to tack the bottom and then weld that up as well. Whether or not, depending on how you can mount this, I am going to drill holes in this bottom piece, but I can do that on the drill press I have with it already welded in, so I'm going to wait to line those up until I kind of get a sense of the stability of the whole thing. Without the shim in here, this piece did warp a little bit more than I would have liked. There's a little there, but when we go ahead to do this side, we'll clamp that down a bit, so I'm not too worried about it. And in particular, I don't have a direct use for this second rail yet, so that's more of a future option that may come into play at a later date. With those tacks set, now we'll check our square. Just going to do some sections here to try and control the warping. Got that down the line with a little bit of warping, but not too much. And again, when we put the face on here, we'll be able to correct for that to some extent. You do want to try and line up your clamps and everything as much as possible to keep things in the ballpark of square. All right, we're going to let that cool down, and I'll come back over on the bandsaw, and we'll start trimming this top piece. This is the top plate. I'm using the 3/8 rather, just because it was on sale. You could easily get away with 1/4. And then I'm just going to mark out here. You have the top rail, medium rail, second mid rail, and then right on the edge here, I'm just going to scribe in where it hits. Again, because you want the tight layout, do this other side as well. Measuring these out ahead of time is fine, but there's going to be a little bit of leeway in terms of how everything lines up with the heat distortion from the welds, and then also you want a nice snug fit on the square tube, so it's easier to scribe it in place. Probably get a better result. There's our two scribe lines right there and right there. That gives us the bottom of the rail it's hit. I'm going to measure it out just to check for square and come back in here with the machinist square and try and line everything up as carefully as possible, and then go across and then mark out our plug holes. Repeat that as well for the top and the second rail. This will also be our cut line on the bandsaw because, again, we need the clearance for the belt to travel through this slot, so we have to use a plate that's shorter than on the other side. This is far from an ideal setup on the bandsaw here, but I don't have a good fence to use in sort of the table format, so we're going to give this a try, see what kind of vibration we get. Just go extra slow and see if we can make it work. I have the slowest speed possible, and I'm kind of babying it here. Not happy. We'll see if we can get through it. Once we cleared the steepest part of the angle, we got a good cut going here. So took a minute to get there, and then we'll have to reverse things around. But so far, so good. Here's the cleaned up and mostly welded piece. I just got it out of sandblaster, wiped it down, get some of the excess sand on there. We also have our cut piece here for the face plate. So it's definitely coming together. This is what gets welded now, although I do need to drill the plug weld holes for the middle piece. So I'm going to lay this down, and we'll mark those out, drill them out. Same process as drilling the plug holes for the main back plate. You can see our beautiful weld here. And looking pretty good here. When you have a camera on, you do dumb things. I wasn't watching the bandsaw, so it drifted a little bit. But that'll be no problem to clean up here. In the weld and size-wise, we're pretty good. Looks like we're mostly square. I'll scribe out where this area is going to be, and then I'll drill it out and come back. We have our plate here that's been drilled out for the plug welds, and I'll go ahead and line it up. We can also just see that the fit is very snug here, very nicely aligned. So I'm not too worried about these. The fit's a little bit loose here. We're going to clamp that in place as we do the last weld. And I've got the plate here. I'm going to tack the top, tack the middle, come do a little filling on those, and then tack the bottom in place after I move this into that slot. And importantly here with the plug welds, I've been playing with a bunch of those. You want to have your high amperage on these cheaper welders. You want your high amperage but a relatively low wire feed, and that'll give you the best chance of getting through to the U-channel securely. If you do end up having problems with the plug welds, just because maybe you're inexperienced as one of your first projects, the other thing you can do is take a MAP gas torch and really heat up the area first, which will help allow you to penetrate. We've got the top bar tacked in place fairly robustly. Now I'm going to tack the middle bar in place while the slide is still here, and you can still see that we're free. Now I'll go ahead and do the plug welds. I'll start in the middle here and then do the outside and then finish up the rest of them. Okay, those all look like they took fairly well. It is important to make sure you're hitting the very bottom inside corner of those holes as you're doing it, just to make sure you heat up the U-channel enough to get a good penetration. While everything's still hot, make sure that you did not accidentally weld the slide in place. It'd be relatively easy to do that. And of course we got some ugly nubs here. That's okay. We'll go ahead and finish those out in a final grinding and clean up before we paint. The middle section here has been welded. You can see it's actually very snug. Probably a little snugger than I want, but again, once the mill scale comes off, it gets greased up, it'll work out okay. And now it's just to brace the supports here. So let's move this around. And it's already reasonably sturdy, but you can see there's sort of that tilty quality to it. And as well, under extreme stress, I did an FEA analysis, and it shows that adding some braces here will alleviate any of the questions about rigidity at all. It keeps the rigidity within a 0.5 thousandths under pretty significant load. So I'm going to cut these to size, and then we'll weld these on this side, and then we just have to do the bracing for the upper pulley that is the tracking pulley, and that'll get us real close to finish. And then of course, sort of a separate project, it'll be building out the platen end of this. The first supporting bar there is lined up. The measurements aren't absolutely crucial, but they're in the drawing. And it's 1.5 inches in from the edge there, and it does cover up that hole, which will just make it a little easier in painting. I'm going to tack it up here, and then I'm going to reset the clamp just to make sure. There's a lot of deburring I had to do on the holes to make sure it lays flat. Okay, we've got that one tacked up. Now for the next one, you can see there's a bit of heat distortion there. I'll make sure I clamp it as I secure the rest of it. You need to leave clearance for potentially mounting the motor on this side, so that affects the positioning of that second one. I'm just going to go double check that measurement. You want to make sure you have that clearance. Same drill as before. I have it mounted over here. I checked the spacing, just dry fitting it with the frame on my motor. My motor is a little different than the one I used in initial design, so you want to check yours to make sure you have enough clearance if you do want to mount it on this side. You do have the option to mount the motor over here as well, depending on how you're going to set this all up. Now I'll quickly tack that in place, flip it over, and tack it again. Very nice. I'm going to mount this to a base, but you have a concrete base. But there's a lot of opportunity about how you'd like to mount it down below with holes, or even welding it to a plate. But even without finishing the welds on those sides, it's pretty darn sturdy. So I'm happy with that. And of course, let's see if we can get some motion happening on the slide here. Yeah, it's nice and snug in there. Snug as well in the top one. So I'll bang that through and then take that over to the wire wheel, start cleaning it up, test the fit of the rest. Now I'm going to start working on the 3-inch pulley. Have the blank for here. The process will be the same as for the 2-inch pulleys. Profile the outside, face the ends, do the recess. So I'm not going to show that again. However, this is the pulley that's crowned so that you can adjust the tracking on the belt. So I'm going to show the steps here that I'm doing to do that tracking. So this is just an M8 by 80 or 100 bolt. There's a lot of different ways you do it. We're going to use this to make a quick, cheap, easy little mandrel so that after we do those other pulley operations, we can mount the pulley. And I've got a little trick here to do the crowning without any kind of fancy attachments, or not super fancy. So let's go ahead and take this bolt. I'll profile the outside so that later we have a surface that we can reference off of. And then I'll also do a start drill, a point for a live center in the other end. I think you can see on there that we have our little point for the live center to sit into. Here's the 3-inch pulley. Same machining operations as the 2-inch. I have that mandrel we made earlier mounted with a bunch of washers here, 20 or so, and that's to extend it so that the threads clear on this end. I have a flange nut. You could use whatever kind of nut you want. So I'm going to secure the pulley to the mandrel. And you want it firm but not brutally tight, because once you put it in the chuck, you're going to have to try and indicate in concentricity and make sure that's right. We have the divot in the end for the live center that we set before. So I'll mount that up and then show you kind of the sanding process. I have it mounted up now, and it's within, give or take, about 1/1000th and a half. So that's plenty fine for the pulley here. What I did is I put the mandrel in first, the bolt, and then just zeroed that in pretty closely. I mean, it lined up with how we did it originally, putting the divot in there for the live center. And then have the head that we rounded off sticking through just enough. There's some washers in there so that it's touching the face of the pulley, the jaws of the chuck are, and then also have some nuts, some washers there to extend the nut out onto the threads. And then I put it in a little bit loose, snugged it in, gave it a few love taps, and then tightened it down as I was watching the indicator. So we're in real close, and now I'll show you the setup to do the actual sanding. Here is our 3D printed sanding jig set up here. It has the compound curve of the pulley, the crown on the pulley that we want, and then I have this they call ultra flexible sandpaper here. This is 100 grit, and it just slides in here, and then we'll use the pressure of the tool post to apply the sand on a very, very slow RPM. Want to make sure nothing gets caught up. And also, this is PLA plastic. It's not very heat friendly, so we need to keep it nice and cool. But it's okay. We'll go low and slow and see how these results turn out. We're going to take a look at how our fixture's holding up. We can definitely see some sanding going on. It's bringing in the edges more so than the middle, so it all looks good so far. And it looks just like our 3D fixture's holding up just fine. So I'm going to increase the speed just a touch here. Just out of curiosity, I went to grab some regular, not the specialty ultra contour, ultra flexible, just regular old sandpaper. I guess this is the slightly better last long 3M variety. Has a slightly rubberized back, and it doesn't seem to make a difference. You don't need the extra flexible stuff. This is an 80 grit. I think I have a 40 grit around somewhere, so that'll just make your whole process go a bit faster. This maybe does want to, because the grit's higher, it wants to pull through a little bit higher. I've been playing with this technique for 10 minutes or so, and I don't know if I can recommend it. I mean, it works. It's going to be very precise, but it's very slow. I will say, threw some WD-40 on here, and that seems to be accelerating the pace a lot. And at this point, it's just jamming up the sandpaper with aluminum grit, pretty regular, or aluminum shavings. And so we'll get there. But all in, this is looking like it's going to take an hour or so, which really is not worth it for a crown pulley. The upside to this is that even if you didn't have a lathe, there's a lot of ways to spin something and press this block against it and get a particular shape. So that was my main interest. You can kind of see here where the WD-40 is present in the middle, so we still have that little bit of gap forming, so we are making progress. I just finished out with some 100 grit. There's definitely some texture to the roller, which is fine. That's from the 60 grit. And I'm not sure how well you can see this on the camera. You know, it's quite a subtle crown we have here, but you can see rolls from side to side. I think this is probably enough. There's a lot of debate about the amount of crown that's necessary and appropriate. My thought is generally the least amount of crown necessary, so you avoid as much belt distortion as possible. So we can always mount this particular pulley back up and give it another touch-up, but I think this will do it for now, and I'll include the 3D print and some of the other information about this on the Knife Lab website when I get that up in a week or so. All told, this worked. It definitely went slower than I hoped it would. The WD-40 made a big difference, made some other oils and things. The PLA is not super happy about that, but this is a one-time use type thing. Mostly I wanted to try this technique because this is an ability to mirror a 3D printed surface on a metal part, at least with some subtle variation, but a relatively high degree of precision. And there's a lot of neat things in the future I might be able to do with that, and I hadn't seen anyone else sort of try this. Of course, you can build some fixtures and things to just do the arc turning of the crown and so forth, but that's a lot more work and materials than 3D printing something and throwing it on the lathe. And in general, 3D printed lathe tools, I wanted to experiment with how that works. And overall, I learned a bit. I definitely would make this smaller, and I might throw another version up there when I have the chance. As a whole, though, the 3D printed lathe tool, there's a lot of possibilities with things like this. I'm going to take this over to the bandsaw and cut off the parts that we need. We need a 10-inch, an 8-inch, and then 3 1/4 nominal, which is the parts that will span here. So you're going to want to measure your actual distance to get those cross braces, just because there'll be a little variability because of the gaps and the shims and the welding and all that. This is the approximate layout of the sort of tower, I guess we can call it, for the crown pulley. So I've got all the pieces cut. I'll square this up, although I just misplaced my machinist square for the 5 millionth time. And then tack weld it all together. The things to watch out for are clearance for your crown pulley. This will actually have that M8 axle. It's just a partially threaded bolt that'll thread into here like so. May have to trim down the edge of the bolt through there. And then, of course, there'll be the hinge here. It's a weld-on hinge from McMaster. It's something like $1.50. Very, very inexpensive. And that toggles up here. Sorry, I can't get my hands out of the way here. That gives you a little bit of a better view of it. That toggles here. And then there'll be the thumb screw on this side that adjusts the angle of the tracking for the pulley. So I'm going to weld that up, and then we'll go ahead and drill our holes on the frame to mount it, and then that'll wrap up this part 2 of the DIY knife grinder build. Almost forgot, the rails up here that support the crown pulley are going to be mounted with a shoulder bolt that goes in here. So now is the time to drill those 2 holes through the left and the right side of it. They're going to line up like this. And it's just easier to drill them together so that those holes are fairly closely aligned. As it welds, there's probably some distortion and everything else, but it's okay because it's not a through axle, it's just a screw in on each side. And I think I have those spec'd as 5/16 holes for the shoulder there. There's a lot of ways you could do this, mount a through bolt, all kinds of things. It doesn't matter if there's a little slop in this necessarily because it'll be the piston that takes up the slack, but this seems like the easiest way to do it. So I'll drill those holes now before I weld everything up. The support rail is mostly welded up. One little trick on that is that you can use a drill bit, I don't know where that went to, through the holes or any kind of shaft just to keep everything lined up. Just a quick image in here to show you kind of how this all lines up. So this way on the hinge goes like this, and then over here. I'll drill that with a hand drill after just to get the positioning quite where I want it. The thumb adjust to control the tracking in and out. So that's pretty straightforward. Nice little setup there, and I'll show you the dry fit of the upper support rail here too. Here's the dry fit of the setup. The shoulder bolts got a nice snug fit here. There's a little bit of weld spatter I'll clean off. We'll hold the upper rail back here, and then this mounts up this way and is able to canter out as needed to adjust the tracking. If you look closely at the tracking pulley, we saw it earlier in this episode, but you'll see it's a pretty subtle crown, but that's really all that's necessary to adjust it. And this thing's been banging around here for a minute, so I should polish it up a little bit more. And that'll wrap up this part 2. So, you know, there's a bunch of finish work left to do, but overall this isn't that bad a project, and really you just need your angle grinder, your cheapo welder, some way to drill. A drill press is definitely handy. But you can get all those tools and all the parts and the motor and everything for still well less than you could spend on a belt grinder of sort of this level of sturdiness. So have a great one. I'll see you next time.